Hi, physicists. We're going to look at position graphs. Most often, a graph is going to start with a table of values. Here we have a table of position as time increases. So we start at time 0, go up to time 5. The x value here is the position, which starts at 2, goes up to 4.5. You can do a scatter plot or a line plot and plot each of those points one at a time. Here we have a graph that matches our table. At time 0, the position is 2. At time 1, the position is 2.5, and so on. Very important here, we labeled our axes. So the x-axis is the time in seconds. The y-axis is the position in meters. Here's a new graph of position versus time. Anytime you see a new graph, the very first thing you do, look at the axes, check the units. Here we have position versus time. And there are 3 clear segments here. The first segment, from time 0 to time 4, this object is moving forward. And one of the ways you know that is if you just think about the values of position as the time is increasing. So here we start at position 2, and over those first 4 seconds, we change to position 4. We went forward 2 meters. In this next segment, we start at position 4 and we end at position 4. During that time, our position is not changing, so we're not moving at all. And in the last segment, we're moving backwards because every second that ticks by, we go backwards 2 meters. We start at position 4. After 1 second, we've gone to position 2. After another second, we're back at position 0. Turns out that if you have a position graph, you can find the velocity. The velocity is embedded, it's in there, and we can find it. If we remember that velocity is displacement over change in time, look at the graph and find the change in position by finding the change in the y value. Look at the graph and find the change in time by finding the change in the x value. So for this first segment right here, where the position is increasing over these 4 seconds, if we look at the change in position, it's the change in y value from the beginning to the end of that segment. So that's positive 2 meters. If we look at the change in time, we'll find it's 4 seconds. We started at time 0. That segment is over at time 4. And this looks an awful lot like rise over run if you've ever seen slope before. And in fact, it is. So when we look at the slope on a position versus time graph, that slope is the velocity of that object. Okay, what is the velocity for all 3 stages of this graph? We just looked at the rise and run of this first segment. It goes up 2 over 4. So that's a slope of 1/2, or a velocity of 1/2 meters per second. This second segment is an interesting one where we don't move at all. The change in position, or the displacement, is 0 over those 3 seconds. And this last one is very interesting, important to note. You can have a negative slope, you can have a negative velocity. In the last segment here, every second that ticks by, we go backwards 2 meters. So we started at position 4, a second later we're at position 2, and a second later we're at position 0. Quick summary. We can graph position over time. And we know that velocity is the change in position over the change in time. And those 2 things are present in a position graph. So on a position graph, calculating the slope is the same as calculating the velocity of that object.